we are going to go deeper into this today. Let me just pull my screen. Let me know if you guys are able to view. Are you guys able to view my screen?
Yes.
Yeah.
Okay, perfect. So we started the discussion around the retrieval augmented generation, where we understood the meaning of these terminologies individually. What do you mean by retrieval, right? Retrieval is not only coming from the database, it can come from the web, it can come from any other source that you could have, right? The source of information can come from different sources, right? But in typical bare bone structure for my retrieval augmented generation, in general, I am referring to that the information would be coming from my vector databases, right? Augmenting and generation is just from the name it suggests that you are adding that information, augmenting that information, whatever the custom information that you have, to the model's knowledge base, right? Adding it to the model's knowledge base to process that information and then generate the response, right? We are not relying on the model's expertise in understanding of our specific domain, right? We do not want model to come up with the expertise, come up with the knowledge of the domain and answer your question, right? We do not want that. We want, even if model has zero understanding of the domain, because I am providing that additional information, right? The task of the model is to use this additional information, generate the response from this specific information only, right? If I am expecting that model process some information and take a decision which is not available in my document, right? That is something that is any additional things that you are asking the model to do, right? You are not just asking to generate the response, but you are also asking to use models knowledge, models understanding, like the understanding model has built during the training process, right? And that is a different scenario, right? There you rely on directly on the model's capability, right? And different models can have different level of understanding, different level of biasness towards certain domain, certain knowledge, certain set of information, right? And versus when we are talking about our RAG platform, we can use any model in here as part of our generation. Like this generation can be done through our GPT models, like the OpenAI models. It can be done through Gemini model. It can be done through Claude model. It can be like Mistral, or like there are many other model that you can use any model, because I'm not relying on the model expertise. I'm relying on the model capability to frame that answer from the information provided. I hope you understood the difference between the generation I'm talking about here versus the model expertise and models understanding, right? If I'm talking about model understanding and decision making, which model I am using, that makes a lot of difference, right? If the model is aware, if the model has a recent cutoff date and you are asking about something that has happened recently, right? Model has that capability or the understanding for that particular data point, right? Versus a model which is trained and has a cutoff date which is very, very old, right? There would be a difference here in terms of RAG, the generation. The difference would be, or the expected, at least theoretical difference would be that the response would be similar. Similar as in the obviously the structure of the response can change, but the answer is same. It's just like you are writing or you are solving a mathematical problem, right? I am assuming a variable name X, you can assume a variable name A or B or P or Q, right? Anything, right? But ultimately the answer we are trying to conclude is same, right? I can name my different variables. So it's like structure can change a bit here and there, right? Obviously different model would have their own way of answering or writing or generating the text, but they all are trying to answer the question from the given document or from the given information, custom information that I'm providing. Right? I hope this makes sense. Now, since we are clear with the basic understanding of this RAG, Why do we need RAG, right? Why do we want model to process some information before we jump in here, right? First thing is, if we are giving too much of context, we discussed this yesterday as well, that if I have a document which is of 5,000 pages, right, and I'm asking the model a certain question, the answer to that question lies in the first paragraph itself, right? First paragraph, first page itself. Why do we want model to go through the whole information, process the whole information, and then come up with the response? The higher the information model is processing, the higher understanding the model is trying to get, the higher the chances that model might miss on the accurate answer, and it might dilute the actual understanding of the overall document, uh, of course, needed for that particular question, right? Hence, higher the chances of hallucination. If we break this into rack form of architecture, we expect the model to have only relevant information to process, and hence the less chances of hallucination, right? When we are having lesser chances of hallucination, obviously a better accuracy, and we are not processing the entire sequence, right? Entire document. We are processing only very limited number of pages, right? If I talk in terms of pages, rather than processing 5,000 pages, I am processing only 5 pages, which contain relevant information about that question only, right? So I'm efficiently using the number of tokens. I'm efficiently using the resources, like, because for per token you are paying some amount, right? You are efficiently using that information, right? So it has a, larger implication, not in just terms of accuracy, but also in terms of how fast the model will respond, right? How fast it will respond, chances of accuracy increases, and the cost is on the lower side, right? Does this make sense? These are some general benefits of why do we want to process a miniature version of the document, or I would say relevant part of the document, rather than processing entire information. We are taking just the relevant part from that entire information piece, right? And then doing the processing and then generating the response, right? Some of the benefits, there would be others as well, but these are some general and good enough to help you understand what are we trying to do in here, right? Now, when it comes to the architecture, right? This architecture that you see on your screen right now, this is the bare minimum architecture that you would expect in when we are talking about RAG. Yes, if you want to implement it, if you want to improvise it, you can add more components to this, right? But this is the bare minimum. If you understand this, you will understand where exactly the new component that is coming up. If someone is adding a new component, let's say here, right? If they are adding a new component at this point of time, you would understand what exactly this component is doing and why exactly this component is needed. We'll talk about that, right? But this is the minimum architecture for retrieval augmented generation, right? Let's talk about each of these blocks in detail, right? So first of all, uh, I hope all of us understands what is embedding, what is semantic search, right? What is that similarity score? What is my vector store, right? All of these terminologies will be used in here. So, since we have already discussed all of these terminologies, all of these concepts, I would just using them into my discussion and passing by. If you have any challenges or if you are not able to recall, then do let me know. We can just quickly finish off this concept in one single line, right? Is LLM also using vector stores to store data? What kind of data you are referring in here?
No, the data that it is trained on.
Mm, No. Why would LLM, why do we need to store the data LLM is trained on in vector databases?
No, so this is used for like efficient retrieval, right? Better
Mm-hmm.
accuracy and less hallucination. You said
Mm-hmm.
so, like so that's why like somewhere is it using any vector database?
Yes, it is. We have a vector database in here.
Okay.
The training data is different.
Hmm.
But from the training data, what I understood is that when the LLM was built, there was pre-training, there was training on the data, training on the domain. There were training
He got disconnected, I believe.
Yes, I'm also not able to hear him.
Yeah.
Yeah, he's rejoining, I think.
Hey, can you hear me?
Yes.
Yes, we
Yeah,
can.
my bad. Yeah, so sorry, there was power cut on my end and the power cut was so sorry for that. It's very frequent in Bangalore. So yeah. Uh, so where were we? We were discussing around the training data. Uh, so yeah, so that from the training data, I misunderstood around that the data used for models training, right? The huge amount of data. Technically, we are not training the model in here. When we are talking about training, the terminology is referring to that we are changing some internal weights and biases of the model. Here, we are not changing those weights and biases. We are trying to play around with our prompt, play around with the context, play around with different way of asking the model or making the model generate that dynamic or contextual responses, right? It's on the solutioning part and not on the internals of the model, right? So technically, training won't be the right word, but on broadly, loosely speaking, you can call it you are training the model.
Got it, got it. So, is this the only way um, to get the answers from the data which is not been trained by LLM? Like RAG is the only method, or are there any other methods also in the market?
Uh, for now, there are like these two ways only that at least I'm aware of.
Okay.
That you can make the model generate responses on your customer two ways. First is you train your model, right? You do the fine-tuning exercise, you prepare your data, you do the
Right.
evaluation and all that part, where you are dealing with the internals of the model, right?
Mm.
Changing the weights and biases. And the second comes in that is my RAG, where I'm exposing my that custom information to the model based on the user question and then asking the model to generate that response.
Got it,
Right?
got it. So in
Yeah.
case of custom GPT,
Mm-hmm.
so there also like we create a GPT for
Mm-hmm.
the data that is not been trained by LLM, right? So like we upload a document and then we ask questions or static document,
Mm-hmm.
right?
Mm-hmm.
So in that case, like is it in the backend drag is used?
So now that depends upon the solutioning that you are using, right? So
Mm-hmm.
if let's say you are using a huge document, or let's say if in ChatGPT itself, you upload a document and start interacting, right? Now that's up to the solution, like behind the scene, how they are doing. Maybe they are breaking down the document, understanding the formatting of the document, uh, building this RAG solution in the back end. And for you, it is just like you are putting a question and getting answer. You do not know what is happening in the back end. That is up to the OpenAI, how they have built that agent. Second can be that entire information that is available in the document is sent to the model, and model is going through that entire information and then generating the response. It's upon the solutioning the way it is built behind the scenes.
It may or may not be,
Right?
but chances are.
It may or may not be. Yeah.
Okay, got it.
Yeah. Okay. Any other inputs? Any other doubts in here? Uh, okay, then I'll jump onto these individual components, right? Okay. So the first part in this entire sequence is these documents, right? And this is one of the, I would say, most powerful part of the entire uh, workflow or the entire architecture diagram, right? Where these documents, like let's say you have a information, that input information which has of 5,000 pages, right? Now, from the example that we were taking previously, that we are breaking down or we are making this information smaller enough, right? So I'm preparing some sort of smaller part of the information. I'm not taking the entire information at one go, but I'm breaking down this document into smaller pieces, and those smaller pieces are called chunks, right? I'm breaking down this entire document into smaller chunks. Chunks is nothing but a manageable, meaningful piece of information that you want your model to process, right? You are breaking down your entire document into smaller chunks, manageable piece of information. Your chunk should not be big, too big, so that it is having too lot of information, and it should not be small enough that it is not even capturing the correct information. Just give me a moment. There's someone on my door. I'll just be back in. Yeah. So chunk is nothing but the entire documents, right? You are breaking down this entire 5,000 page of document into smaller, manageable, meaningful pieces, right? You can break it down on per page basis. Yes, for each page you will have one single chunk, right? It should not be big enough. So if you remember that when we were talking about embeddings, this particular document, this particular chunks, we are going to convert them into embeddings, right? So the information inside that chunk should not be huge enough so that it is diluting the actual meaning or actual content that it may store, right? If you have single vector talking about n number of things, right? The net vector is trying to capture the meaning of all that part that is available in that particular chunk, right? Hence, it may not be able to capture the essence of each one of them, right? It may capture for one, it may capture for two, but when you are collecting like a more like a lot of information, you are dumping the entire information into one single chunk. It may dilute the entire sense of information. Or if it is too small, right? Again, it may not be actually capturing the real meaning, right? Let's say you have rest of the like you have one document or one single chunk which is capturing only one single line, and you have some other chunk which is capturing, let's say, a single chapter. One chapter can have multiple pages, right? So if you are doing either ways, you are not actually capturing the right essence inside this particular scenario, right? So collecting or getting to the right strategy of how you break down your document is the key in here, right? We'll discuss some of these strategies in detail. But the idea in here is we need to come up with that balance in between, right? Where I will break my document in such a format that I'm able to retain the meaning, even if the information is spread across the document, even if the information is available in my images, how I'm able to retain that information truly inside my vectors, right? That is the whole purpose of doing this exercise, right? So I'm going to first break down this process. This is called my chunking. Once I have these documents, the input document, and obviously the input document can be different sizes and everything, you have broken down into smaller pieces. Now, let's say we are taking on per page basis for just for an example, right? We are breaking down it at per page basis. So if my original document has 5,000 pages, now I will have 5,000 chunks. right? Now these 5,000 chunks needs to be converted to embedding. Any embedding model that you are using. Let's say you are using all mini, right? You are using all mini model, which is of defined size and everything. You convert these 5,000 documents, or I will be calling this term interchangeably, that you have 5,000 documents. Will tell you why. That I have 5,000 documents now. Earlier I was having one single document. Now I have 5,000 documents, right? This 5,000 documents, I'll be converting it to embedding and putting it in my vector store. Now my vector stores are specialized databases just to store those vectors, just to store those numbers, right? Uh, is it something that you can work around and do not use vector stores? Yes, you can do that. But in that case, you have to do a lot of calculation. So the vector store is not just only storing those vectors, it is also helping you perform those calculations efficiently, which you will be doing when you are retrieving the information from your vector database, right? When you are doing that similarity search, semantic search, all that databases are specialized in doing that kind of processing. Hence, you can use you need to use those vector stores for faster processing, faster retrieval, faster storing, and all that purpose. You store the entire information in your vector stores. Now the backend part is ready. So this is part of your backend, which you will process information, you run through this pipeline and store it. That's it, right? It is not going to only when you need to do some experimentation, you need to try some strategies, or you need to play around with different embedding model, or you need to play around with different thinking steps, right? Then only you change this backend pipeline. Else, this will remain frozen in time when you are consuming the pipeline, right? Now, since I have this backend part of the pipeline processed, stored, and available and ready to use, right? Now my user question comes in, right? This is where this is a part of the pipeline which is going to run when like more frequently, right? User interaction basically. The user query comes in. You from this user query hit the vector store, right? Now you know vector store is prepared, vector store is ready to be consumed, right? You retrieve the relevant information from your vector store, right? Based on similarity, maybe you can say that I want anything and everything which is 80%, more than 80% similar based on this user question. Or you can say that I need which is top five. I need top five, even if the similarity is 0.3 or zero point 0.4, I need top five, right? Or you can do a combo of these two where you can say I need top five, right? But the similarity should be more than 80%, right? If the similarity is less than 80%, I'll cut it. So in this particular scenario, you can get max 5, right? And minimum 0. What if in the scenario the document does not have any information overlapping or having a similarity more than 80%? So you can get 0 document in return, right? So that's how you dynamically do the retrieval based on whatever the state you want to adopt. And once you have this information retrieved from your vector database, now my vector database, I understand how I have the information, how the information is available in my database. I do the processing, attach this all information as part of my prompt, send it to my LLM. Now, my LLM understands the question. My LLM has instruction, right? It has the context, it has the question, right? And you can add some rules, right? All that stuff. And the LLM is going to generate this response, right? All this becomes part of your prompt. Whatever the context that you have retrieved dynamically also get added as part of your input prompt, input context that goes into the model, right? And now my model generate the response based on this context, right? Does this logically make sense? Rather than processing entire 5,000 pages, I am maybe processing 5 pages or 3 pages, or the number of pages that you want to define using whatever the strategy that you're using. right? Does this make sense logically to put it this way? Yep. Okay. That's great. Now let's jump in a bit more detail into each of these components, right? Because uh, yes, bare-bone, it's pretty easy, right? There's not too complex. Everything seems to be logical. That obviously you will be breaking down the document, storing it somewhere, retrieving it when as and when needed, and then including as part of your context and consuming it, right? It's pretty straightforward, right? But let's understand some of the nuances in this particular uh, architecture, right? So what is my vector store, right? Vector store is just easy to manage vectors. It stores that vectors, and it helps you do that pre-processing when it comes to the retrieval, right? It is storing that information, indexing that information, and whenever you are hitting, and obviously I missed one thing in my previous slide. Let me bring that up. Is I'm sending this query, right? And I'm using the same embedding model. If I am using ADA, then I need the same model to convert the natural language question, the question that you come has come from user, right? I need to use the same embedding model to convert the input question to embedding and then send those embedding for retrievals, right? It cannot work like that you are using ADA model to generate the embeddings and then you are using all mini for the retrieval. No, right? Because it doesn't make sense to compare two different methodologies of generating those vectors, right? You are comparing two different techniques of encryption. The results may not be as you would expect, right? There can be issues in that retrieval. The difference between semantic search and similarity search, I missed that. Yep. Yes. Semantic search is again that you are searching based on the meaning in captured in vector, right? Semantic search is like you are doing this embedding search, and similarity is you are putting in some threshold in there, right? You are putting a similarity threshold of, let's say, zero point 0.8 or zero point 0.5 or zero point 0.7, right? You put that threshold and then do the retrieval, right? So these terminologies you can choose. You can choose to use interchangeably. LLM needs to connect with RAG. Can you help me understand what exactly you are referring to in here when you say LLM needs to connect to
Yes,
RAG?
yeah, Ankit, I thought this vector stories are RAG, right? And LMM needs that data to respond to our queries.
Mm-hmm.
But I'm not
No.
sure I
So
missed
this
something.
this entire architecture is called RAG. It is not just the vector store that is called RAG. First thing. Second, here also LLM is connected to RAG. LLM is connected to the vector store, but not directly. We are retrieving the information dynamically. We are controlling the information that will go to the large language model, right? And then model is considering that information, using it in the context to generate the response, right? Does this
Okay,
make sense logically?
so this entire thing is RAG itself, is it?
Yep.
I thought the vector. Sorry, I missed something. Okay, I thought only the
Mm,
vector store actually forms a data store. Where we say it
mm,
is RAG. Okay, and
mm. So from the name itself, like you can connect with the name itself, right? I'm doing the retrieval from the vector store. This is my R, right? I'm augmenting this
okay,
information to my model. That is my augmentation, right? And I'm generating the response using the large language model,
okay,
right?
okay,
I'm retrieving also, I am augmenting, and I'm generating the response. This is what the entire sequence requires, right? For retrieval part, I have to process certain pipeline beforehand. Then only I can do the retrieval part, right? And that is part of my backend pipeline.
okay.
Consuming this is lot easier. processing is where the actual game lies, right? If your model is not performing well, if you are not able to get good answers, or you are getting some miss, that all relevant information is not coming up and all that exercise, if you see that model is not performing good, you go dig deeper, relevant context is coming up, then you need to maybe tweak something, the way you are breaking down the document, how you are consuming or how you are pulling that information. Yes, certain thing you can change with respect to the threshold that you are using in here, right? Top K information that you are using it here. But there is a lot more that you can do in your upstream pipeline, right? Maybe try changing your embedding model, or maybe try changing your embedding this chunking techniques. How about that? Maybe you have different types of document does not support the way of chunking that you have put in place. So maybe you want to consider, just like here we are breaking it down on per page basis. What if the per page information is not the best for the specific document? And I'm sure you will come with this question, that what is the best chunking strategy? If not right now, maybe a little later. So for that, let me clear it. There is no fixed answer to this. It completely depends on the kind of document that you are dealing with, right? If your document has tables and images, the chunking strategy would differ, right? Or the approach would differ. Or if you have a document which is properly labeled, properly having headers, having subheadings, having bullet points and everything, completely changes. If your input information is just the blank text and the information is randomly scattered here and there, right? Some information is available on page one, similar to the same topic information is available on page 3 also, page 5 also. So if you have scattered information like this, right? Documents can have different formatting, different structures, right? So for that, you may want to explore different types of chunking strategy that are out there, right? It is all part of how you improvise on your overall response from your system.
Yeah, Ankit, one thing, the A part, right? When we say LLM doesn't have any memory, right? So how will it
Mhm.
respond to the G part, right? As per this architecture.
Mhm. Yes, by default, model do not have the memory, but by augmenting that additional context, don't you think we are adding additional information? So let's say right now you do not understand about, let's take some complex field, maybe quantum physics, right? I do not understand, let's say, about quantum physics, but I understand English language. I understand the sentences. I can interpret the meaning of those sentences, right? Now, let's say you ask me a question about some quantum physics, right? And you give me a book, right? Or let's say book can be too huge. Let's say you give me 5 pages and you say that, okay, this is the question, and these 5 pages has some information about this question, right? Use this information available in this 5 pages to generate response for this single question that you have provided, right? It's like an open book test. You go through the document. I'm understanding. I'm because I'm able to understand English, right? I'm able to make sense of what is written in there. I use that understanding. I'll go through the document right then and there and generate the response for you. That's what this LLM is trying to do in here, right? I do not have
Yeah,
understanding
so
of quantum physics by default, but because you have given me those 5 pages, that's where I'm building my understanding on.
yeah, but is it not better along with question I'm giving you context as well, right? Is it not better I feed you with context itself and just give a query, that's it, for better retrieval?
Uh, Better retrieval, as in you are talking about this part of the
Yeah,
scenario?
query to core, query to context, query prompt to LLM, right? I'm
Hmm.
giving a query along with that context itself. Now, how you told, right? I'm asking question. I'm giving a book as well.
Hmm.
Shouldn't this be like, take this book, study it? Now I'll come with a different set of queries with you.
Yeah, that's what we are trying to do, right? We are giving the question, we are giving the context and asking the model to generate the response. And now it depends. If you are giving the entire book, I will take time to go through the entire book. I may miss on something that was available in the initial pages, right? If you
Yeah,
give me
but
very
this,
specific 5 pages, I can quickly do it. I can efficiently do it, and the chances of getting the right answer is on the higher side, right?
okay, but this, you know, I've this diagram itself confusing. When you see like query, right, it looks like
Mhm.
query will go to vector, form, context, query prompt, and then it will go to LLM. Like
Yes.
every
So
prompt. Yeah,
yes, every prompt will go like this. So let's say I ask first question. For first question, I will do the retrieval. I will convert it to embedding and I will do it, right? Whatever the chunks has come, whatever the information has been retrieved, I use this context, I take the query and I prepare a single prompt, right? So this prompt contains the retrieved information from the database and the query that user has asked. Now this is the final context that goes for my large language model to understand and generate a response. Now user asks a question number two. The information that was
yeah,
used in first question, the 5 pages that you have given me for the first question, the second question may use those different 5 pages, right? That dynamically I need to
okay,
retrieve from
okay,
the database. So that is the dynamic retrieval happening for each and every query. Each and every query has to go through the same path where I'm doing the retrieval. I am adding it to the context and I'm asking the model to generate the response. So these
okay,
5 pages will be dynamically changed based on the user question.
good.
So, but if I ask the same question again, are there
Mhm.
any chances that the output may be different, like say 20% different, as it is?
Then that
Yeah.
depends upon how your things structure is configured, right? So if you are asking exactly same question, right?
Mm.
I mean, say word to word same question, the
Yes.
embedding that is generated will be word to word same, right? We'll agree to that because I'm using the same embedding model. And yes, the underlying assumption is I'm using exactly same embedding model. I'm using exactly same vector store, right? I'm using exactly same thresholds, right? Considering that scenario, right? If I'm putting in the same question, embedding generated would be 100% same, correct?
Mm.
You'll agree to that.
Yes.
100% similar embedding will give me, if I am putting top five, right? The store embedding are also the same. The query embedding are also the same. The retrieved information will also be 100% same. Correct.
Mm.
Now
Right.
adding that as part of my context. So at this point of time, the information will be exactly the same. The retrieve context, the user question would be exactly the same, right?
Mm.
But you cannot guarantee on your LLM part the output structure will be 100% same. I'm talking
Mm.
about structure, not the content. Content would be there are very high chances that the content inside your response would be same. Yes, that is very high chances it would be. But on the structure part, structure may not be the exactly same the way you have got in your first question.
Got it. Got it. Mm.
Can you walk through? Yeah, we will do that. Don't worry about that. Yeah. Okay, so this is the entire sequence. This is the entire workflow, right? We'll go in detail in these how I'm breaking down the document, converting to embedding, how I'm putting it into vector store. All this stuff we are going to go through in detail. Don't worry about that, right? But right now, the idea for this discussion was to give you a broader picture of how things are connected. Now we'll go deeper and fill in those blocks, right? Right. No, so now let's just jump into individual components, starting with the vector stores, right? Obviously, we are just putting in these numbers in there, right? And internally, there are algorithms when you are doing the retrieval part, right? You are not just doing those mathematical calculations directly. There are algorithms which are more complex, trying to give you more efficient, more faster results, right? That is whatever vector stores helps us in, right? And along with that information, along with that, the page information, the actual information that you are storing in your vector, right? You can attach some additional information with each vector that is called my metadata, right? So in metadata, maybe you want to store that what is the document title, right? Maybe you want to store page number, right? Maybe you want to put author name, right? You want to store where and who manages vector store. We'll come on to that when we discuss this. Just give me one moment, right? So this is the metadata information that you can store in the along with your actual vector, right? Maybe you can also store, let's say, original info. I'll tell you why we are referring to this origin info. Just one moment on that. That we can store these different kind of information in my vector database, right? Obviously, the main content in this is going to be my that text, right? That natural language text that will be converted to vector, right? But along with this vector, you can store couple of key fields that is my metadata, where this metadata will be used when you're retrieving the information from your database. This additional information will help you connect where exactly this information has originated. Let's say you want to apply some filters, right? Let's say you want to apply some filters on the author name, right? You have 50 different books. You want to apply a filter on a specific author, right? And for a specific author, let's say you have selected author A, right? For this author A, you have only 20 books in your database, right? Now the retrieval process will happen only on these 20 books because you have applied a filter already in place, right? So this is where our metadata information helps us a lot, right? Second, when I mentioned that original information, right? This original information may not be helpful in filtering, but it can be helpful in efficient retrieval. How? I'll tell you. That let's say you have a sentence, right? You have a sentence which contains obviously some stop words, right? Let's say the, is, and certain words which are not adding to the meaning in the sentence, right? They're not adding too much into the meaning. But obviously, because those tokens exist in your input statement, hence the embedding will be created. They might drift away from the actual meaning that is coming up in the sentence, right? Maybe little, maybe less, but all those punctuation, obviously, punctuation is also a token. Those stop words are also the token. Stop words, when I'm saying this, the, is, and the, are, them, these kind of words, right? These are all called as stop words, right? So you may want to clean those words when you're converting to vectors, right? So this particular information that you are converting to vector, this will be your clean information, right? This is your clean information converted to vector. But when you are consuming this information retrieved from the vector database, right? Because you are sending this information to the LLM, it has to form that structure, right? You do not want to lose on the structure also, because if a particular statement is forming a sentence, right? That sentence has that meaning, right? You don't want to your model to see some abnormally formed sentence, right? It has to be a proper sentence to make the correct meaning out of it, right? With all those punctuation, all those stop words and everything. So that's where I store my original information. I do the retrieval on this clean information that I have put in place. Obviously, because I am doing the some processing on my input text, which I'm converting to vector, I'll also need to do the same processing when I'm doing the retrieval part. So on the question as well. It's like you are doing that level playing field, that you are cleaning the content in your vector and you are cleaning the content in your question, and hence you are doing that similarity score calculations, right? So this is where your original information can help you in, and you can store all this information as part of your metadata, which can help you in filtering as well as better context management, right? All that stuff you can do. Now, when it comes to different types of vector store, right? Can we call this as fine tuning? No, fine tuning is a different thing altogether, right? Fine tuning is something that you are again. So in when we are talking about fine tuning in technical sense, we are referring to the changing the weights and biases, the internal. Remember from our neural network discussion that we are trying to tweak in the weights and biases of certain layers in my overall neural network, right? I'm not changing the entire neural network, but I am going inside the neural network and doing some tweaking based on my custom information, right? That's what I'm doing. I'm doing that RLHF, if you remember. right? Reinforcement learning with human feedback. I'm trying to change something internally so that when the information is processed, the calculation is adjusted accordingly based on my custom tweak of parameters, and hence the output in similar fashion, right? Here, I'm not changing anything inside the model. I am just adding to the context. And this becomes part of my prompt, the fine tuning through your prompt, right? Through find If you remember, we discussed this as well, that just the way you write the information, certain part of your neural network can have higher impact on your overall answer, a certain part can have a lower impact, right? Just the way you write your prompt, just the way you tune your prompt, right? The structure and everything. You can also put it as part of your fine tuning, but in typical scenario, in technical sense, we generally refer as fine tuning, where we are talking about internals of the model, right? And here we are doing, and here we are trying to do that prompt wala part only. We are storing it into the vectors. We are retrieving it from the vector, adding it as a context. So we are trying to play around through the prompts, right? Now, when it comes to different types of vector databases, some of the popular ones that are in the industry, like Pinecone, Chroma, Fice. Chroma is from Microsoft, Fice is from Facebook, Quadrant is one open source vector database. Pinecone is again proprietary one. It is also good. Now, there is a difference between these, right? Uh, Obviously, there won't be a lot of difference. All of them are trying to store the information. Again, today you are, let's say, using Chroma. Tomorrow you want to change to Files, right? Again, LangChain is helping us do that stuff. Remember, LangChain is trying to make our life easier when we are trying to switch between these models or between these vector stores, right? So changing from Chroma to Files is as easy as just changing a couple of lines of code rather than changing everything wherever your vector store is used, right? So again, LangChain is going to help us in here. And because LangChain is helping us making that or using that abstraction layer, it is also helping us in abstraction, if you remember, where it gives us the visibility, right? So when we are talking about observability, it will tell us what is the exact information going for retrieval and what is the exact information that is retrieved. It can give you that explicit visibility on all this context, right? Does this make sense? Yep. Okay. Now there is a couple of difference that you would want to understand when you are playing around with databases, right? So my Chroma and my files, these two are my file based. These two are my file-based vector stores. Versus when I talk about my quadrant, when I talk about my Pinecone, right? They are available on the server, right? So whenever you are creating this Pinecone instance or quad instance, you are connecting to vector store that is hosted somewhere, right? For Pinecone, you cannot host it in your own environment. It is proprietary. It is not open source. For Quadrant, you can host your own model, give the endpoint where your model is hosted, and you can connect to the model, right? But what is the difference between your file-based and your serverless this vector database, right? How many of you understand this and so obviously I believe someone we do have someone from the back end, so they might understand this. Do we have someone who is familiar with these terminologies? Maybe you can share your understanding. Yep. No, it is not about temporary and permanent. Both of them are going to be permanent, right? So my Chroma and files, they are my file-based vector store, right? These two are my file based versus when I'm talking about quadrant, when I'm talking about Pinecone. These are available on the server. I can have the endpoint. I can connect it to the endpoint. My server can be somewhere else. My application can be running somewhere else, and I can connect them through some endpoint, right? Some API endpoints. So if response include metadata plus web, how VectorDB works? Uh, can you explain this a little more? What
Yeah,
is
I mean,
the yeah?
if my in RAG always response, can we expect from metadata or it can be mixed also, right? From web data plus.
No, it's up to
Vector.
you how you want to structure your solution, right? Not necessarily you always want to pull information from your vector database. Not necessarily you want always from the web. Maybe you want to combine them both. And metadata is something that is up to you, right?
Okay.
So let's say I'm cleaning the information in my vector, right? So I want to store that original information in my metadata. So when exposing this information to my LLM, I don't want to show that clean information that I have processed information, right? I want to show that original information, right? So maybe I'm using the metadata information. I'm not just showing all the metadata directly to the model. No, I am showing only the relevant information to my large language model,
Yeah.
not the
Okay.
entire thing that I'm storing.
Explain. Okay.
Yeah.
Yeah. Got it. Thank you.
Yeah. Okay. Yeah. So is it file based or is it deployed on the server?
See, I just tried in cloud actually. It's a file
Mhm.
based one. Yeah, I just uploaded the PDF.
No. So, okay. Okay, then let me just add to the understanding of what is file based and what is on the server, and then then you
Okay.
can explain that which one is it, right?
Hmm.
So let's say you are using Chroma or files, right? When you're creating an instance, there are two ways or two uh, 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 the content that you can be dynamically passing to the model, right? When you're creating this instance, right? When you're creating this instance, you can give a persist directory. If you want to persist this vector store, right? Persist as in you created it right now, you want to store it somewhere, and tomorrow when you come back, you want to directly pull it from the same place, right? You do not want to keep on creating every time. You want to persist that vector store at some defined location. You give the directory path, right? If you give the directory path, a new vector store will be created at the defined directory. And when you are consuming it, you use the same directory. You point to the same directory when you are creating the vector instance and retrieve the information from that vector. So it's like where exactly you are storing this information. Where you are storing it, you are also consuming it from the same location, right? And this location, this persist directory location is going to be somewhere in your drive, right? Somewhere in your folder, wherever you are building it, right? What exactly behind the scene this is doing? It is going to create that folder. It is going to create that files, right? And these files will be storing that information. These are the files. It can be a SQLite file that is created. There the different Chroma and files have different way of creating those files, right? But they're creating those files. If you want to move this file from one location to the another location, you can easily do that. It's just a folder that is available for you. You can copy this folder, you can paste it somewhere else, you can start using it there as well, right? It is as easy as just copy and pasting this folder to a different location and start using it, right? But when it comes to your server based, right? You do not have this folder available for you. It is available, the vector store is available at some endpoint on the server, right? To connect to the server, you need to give that endpoint, right? You have a defined dedicated endpoint. You connect to this server and then store your information plus store. Or you connect to this server and retrieve the information from your vector store, right? So the vector store is at a defined location which is not on your drive. It is available somewhere else running on some server, right? That server can be a private server that you have hosted. That server can be on the cloud, on the web. You connect to you connect to the endpoint through some API calls, right? Through some API that is dedicatedly generated on your account, right? So you have that configuration in the overall architecture, right? So that's how you understand, or that's how you make a decision which particular type of vector store you want to use. One challenge that we faced, right? So when we were on the initial phase, we were using files, right? Very initially, when we were doing, we were using this files based, and there comes the challenges when we are using a file base, right? So let's say you have a single file available, right? And you have one user using it. It can be easily connected. You can easily use it. You can easily consume it, and rest of the thing will there won't be any lag. There won't be any delay. There won't be any unnecessary things that is happening in the backend. But let's say at the same time, you have 10 different instances trying to read the same file, do the processing, right? Or let's say on the parallel, you have 50 instances that are trying to read the file from exactly same location, right? I'm sure the backend engineers would understand that what problem it can cause, right? It can cause that unnecessary delay, unnecessary lag in the system, right? Because just to read that file, the limitation is just to read that file. If you are able to read that file, you will do the processing in memory, right? Obviously, that the processing is happening in memory, but if you are not even able to read the file, you are blocked for the duration till the time you are able to read the file. So as soon as you scale the solution, this file-based vector database can hit a bottleneck, right? And that's where you understand that, okay, now we got to migrate to maybe a server-based vector database, right? So now, so it should be persistent for me then. Not wrong. It we used to Docker container to store the. Yeah. So yes, it can happen that your vector store is running in some Docker image. Yeah, that can be possible.
So AWS S3, if I use AWS S3, then it will be a Pine Core or Quadrant.
No, it is not about. So which particular database you are using, first of all?
No, like if so, it's like we have AWS in our
Mm-hmm.
company, right? And say
Mm-hmm.
suppose I want to create a vector database, and if I use AWS S3 as a file
Mm-hmm.
system to store the
No,
vectors.
I agree, but which particular vector store you are using? You are just using AWS as a AWS S3 bucket as a database, but which particular vector database you are using?
No, no. So, like I'm saying, like if I want to use as AWS
Mm-hmm.
S3, so
Mm-hmm.
it is also file based, right? So it stores the files, right? So in
Yeah.
that case, will I go for so here also like I need to connect to an endpoint and then fetch the files from the bucket,
Mm-hmm.
right? So
Mm-hmm.
in this case, like will it be a pinecone? Can I call it like a pinecone
No,
storage on AWS S3?
no. That is completely different. So even if your file is stored on the cloud, it is still a file, right?
Right,
The directory path can be in your local system, and the local system, it will create that folder, it will create that internal vector, it will store in its formatting, and whenever you are retrieving, you are reading it from the same dedicated directory path,
right.
right? So again, it is similar to your so even if you are using files and chroma and your persist directory path is available on your S3 bucket, that is still a file based system, right? It depends on what vector database you are using, right? It is
Hmm.
not about S3 or ADLS, right? It is about which vector store you are using, and that vector store, how is it storing the, it's not you directly who is storing. You are choosing the vector database, and vector database is storing those and where exactly do you want to store. You are just defining that path if you are using that file based, right?
Okay. So like it's like I'm using a vector database,
Mm-hmm.
and then the vector database will store the data on AWS,
Yeah,
right? But still,
yeah,
but if you see S3 is a file system only, we'll have a folder, we'll have a file.
yeah.
Now, in that,
Yeah, sorry.
yeah, in that case, we cannot use Pinecone.
Yes. So Pinecone is a very dedicated, so it is not available open source. You have to create the account. You have to get those API keys. You have to create the vector like the index, right? You have to
Mhm.
define all these parameters, and whatever the vectors that you will be storing, it will be available on there, right? On their cloud server, on their, and whenever you want to retrieve it, you need to connect to their server and collect the information
Okay,
with
okay. They have their
that
own
API
server.
key and everything.
Oh,
Yeah.
got it, got it. Okay.
Yeah. And
It's clear.
similar is the case with Quadrant. You can either host it, right? You can have your own Docker running this image. You connect to your own Docker image and store the information, right? Or you connect Quadrant Cloud, that is also available, right? You
Mhm.
just integrate it through those API keys.
Got it, got it. No, clear now. Yeah.
Yeah. Okay.
Also, one thing, I don't believe S3 bucket is a file system, right? It makes us feel like it's a file system, but
Mm-hmm.
it's like a SaaS as a service, right? What I believe, this file based system is something like storing like in a flat like EBS volume or some other volumes, right? Those are file system. But if it needs to connect with S3, it should be a different support where this products provide, but it's not a flat file based system. It makes in view it makes us feel like it's a file based system, but it's a SaaS service. You have to work
Mm-hmm.
with the proper API with that to work, unless it
Mm-hmm.
supports this product support. But it's
Mm-hmm.
definitely not a file based system when we relate with like EBS or other volumes, right?
Mm-hmm.
NAS and all those things. Those are
Mm-hmm.
file based system for me. That's
Yeah,
what.
yeah, that can happen, but the idea in here, the point of discussion is not on whether AWS is a file based or not a file based. The idea in here to understand how the vector stores are working. How so when it comes to choosing which vector store you want to go with, right? More or less, they all are doing the similar job, right? But which one you would want to go with, right? Maybe when you are starting, when you are doing the experimentation, you can live with the file based, right? But when you are scaling this solution, maybe you need to consider to move away from file based system and consider some other vector store, right? That's the idea in here.
The given example that you are having about the document that we have in the prior screen
Mhm.
or slide, you can say. So the question is like, are you saying that we create a vector database for a document, given a document? It can be like a kind of architecture document or a kind of a story document, or it can be variants, correct? Are you saying that for all purposes we can have uh, similar structure to use?
No, your input document can have different types of structure, right? Not necessarily that your input is always going to be of defined properly, having headers, having subheaders, right? Having bullet point. Not every time your document can have the same structure, right? Sometimes your document can have images, your document can have tables, right? How do you process that? That is completely up to you. That has nothing to do with the retrieval part. That has nothing to do with the augmentation part. Each of these components can have their own individual challenges, right? And once connected, they can work seamlessly, right? But individually, they can itself has their own challenges, and you can work on how you can improvise on those challenges, right? So let's say you have an image in your input, right? So one way of dealing with images is once you identify that, okay, there is an image, you generate a caption for this image, right? You make another LLM call, you send this image, you generate the caption, you use those vision models, right? You have the caption. Now you can replace the image with that caption that is available, right? And you can store this original image as the path where exactly you are storing this image, right? So whenever this particular chunk is retrieved in your overall scenario, right, from the for based on user question, if this particular chunk is retrieved, so in your argument or in your context that you are sending to the model, you put that image in there. You can do that, or you let alone you keep the text in there, you generate the response, or you may want to put in that image in there as part of your context and then generate the response, right?
So
That's
being a backend
completely
engineer, we are
how you
creating this
want to handle different kind of document.
okay. So being a backend
Yeah, please go
engineer,
ahead. Mm-hmm.
being a backend engineer, we are creating these vectors like based on the context. We are
Mm-hmm.
creating the vector, we are creating endpoints, we are retrieving it.
Mm-hmm.
Down the line, like, is it managed? How is it manageable? We are creating a number of things, correct? So how do you even remember? How do you? Is there any way that like easy to manage this kind of things, or is it like grow like anything?
Uh, is it too? So there are like a couple of touch points in the overall pipeline, if you will see, right? One is like chunking, right? Obviously,
Yeah.
the first step that you would do, right? First is chunking, second is your vector store, third is you are retrieving and adding it to your LLM. There are only just three touch point, right? Embedding model, you can choose any embedding model. You can do the experimentation, you can do the research, which embedding model is working better, right? You can do that part, but that is something that you can start with. Let's say you start with ADA model, right? OpenAI ADA model. The model is good enough so that you can build it even today. Like if I tell you, even for our product in production, we are using ADA model, right? I did that research that if I do that comparison between different models, I didn't see a lot of difference. Yes, there was a difference, but it was not significant enough so that I go and change my embedding model. I can live with ADA model for that matter, right? But the main areas where you can do the improvement is the way you break down your document, right? The chunking strategy. That that's where one of
I'm
the
particular about
critical
this
point is.
vector database. You said we need to create endpoint to access this vector, correct? So I'm considering that how many endpoints, like different scenarios, different vectors you need to create, correct? So every time, how do you remember, like out of today we started with one endpoint in the vector database, either it can be a file based or database. Eventually,
Mhm.
how do
No.
you even
Okay.
yeah,
Yeah, got it.
manage?
Yeah. Got it. So inside your vector store, when we are talking about, right, how it is
Yeah.
organized, right? Some call
Mhm.
it so this Pinecone call it as namespace, Quadrant calls it collection. So it's like folders within your and let's say within your namespace you have index, right? In Pinecone you have something called as index. Within one index you can store multiple vectors. So let's say you are building different use cases altogether, right? I'm talking about different use cases altogether. You have same kind of document, you want to do the filtering, do the processing, entire thing will become as part of your one vector store, right? When you are talking about uh, one single vector store storing different projects, different use cases altogether, right? Everything is available on one single vector store, right? For Pinecone, you create different indexes. This quadrant, you have this collection, and within one collection, store all your vectors. You can apply all those filters, you can apply everything, right? So within one vector store, you can have like this setup, right? So it's one thing, just change the collection name or you just change the space, right?
Oh,
Even files use names. Change the namespace. Let's say I am building it for, let's say, experimentation 101. This is your the name of your this collection name, right? You every time you are retrieving, you define what collection you want to retrieve it from. When you are configuring this, you define all this, that where exactly I'm storing at defined endpoint, right? This is your endpoint. What is your namespace or the
Right.
right? Where exactly you want to point it to. Your endpoint remains same, irrespective of that. Your collection will change or your namespace will change depending upon, say, your building, you're calling something, right? You are working different part or different projects altogether, or for that matter, right? You can use the same vector store, right? You can store, let's say you have one vector store that is for the, like, let's say development, that is deployed for internal employees, the pure development and all that stuff. All are using the same deployment, right? The same vector store. It's just that everybody has created their own namespace or the collection name, and they are not conflicting with each other, right?
So at the
Does this make
architecture
sense?
view, being as like architect, assume you're being a role of a architect. So having these endpoints in your requests or response, will it definitely kind of its own life cycle, request and response life cycle, correct?
Mm-hmm.
So does
Mm-hmm.
it make the total overall response low when we, if it is anything cloud in your in-house system, then probably access is easy. But if you rely on a third party, again, the request respond, the internet, a lot of factors come into picture, correct?
Yes, yes, I completely agree to that. But till now, so when you are building this use case, you will not have, like, you are running the query in, let's say, a server that is hosted in India, let's say Mumbai, and your vector store is hosted in US region, right? Very, very difficult if you have this kind of, but even if you have that kind of setup, the response time is typical. So I have used in my organization, we do not have this that I am hosting it in a different region altogether, right? But generally it takes less than a second to send your request, do the retrieval, return back the content. Obviously, the time is going to vary depending upon the number of vectors you have in your vector store, right? Data size. If you have 100 vectors versus you have 100,000 vectors. Obviously, because in the back end there are some calculations happening, how those calculations are optimized, how those algorithms are optimizing the overall execution time, that obviously will be a factor. But in general, what I've seen, thing in the same region, clusters namespace, and we typically have around 200, 300, 400 in our databases. It typically takes less than 1 second, like maybe 0.2 second, 0.3 second. That's what the time it takes in the retrieval. And we
Thank you.
observability layer, so we can actually pinpoint how much time it is taking for each call and everything. We have that observability.
When you
Right?
have file system and database, is it similarly like is it endpoint that exposes this, whether it's a database call or whether it is a kind of file system call? It's same endpoint that we
Uh,
interact with.
So if you are having a file base, now where exactly is your file? Is it deployed on, is it available in the same cluster when you are deploying your application, or is it available at some other cluster and you want to connect it somewhere else and all that stuff, right? That depends. If you are having it
Okay.
within the same cluster, it would be relatively quicker, right? Compared, if you have five parallel instance running, all of them are trying to read from the same instance, right? Then it can become
Okay.
blocking. Or if you have 50 parallel running, then it can become blocking. So maybe you want to keep it separate somewhere. If you are keeping it separate somewhere as well, then also, even though you are putting the load on the server to read and write the read, no, not write obviously, but the read content from your database, right? Even then it can become blocking. So it's, when you are scaling the application, it's good that you jump onto that server based where you can parallelly run those requests without
Got
the
it.
blockage here.
Okay. Got you. Thank you.
Okay, so any other doubt, any other input in here? There are other as well. These are not the only databases. There are other as well. You can feel free to explore whichever you want to use. You can be good to start with, but these are some of the basic one. Really easy to start with, just a couple of lines of code, and you can get started, right? Uh, okay, so now let's jump onto the chunking. One of the most important area in the overall performance of your RAG solution, right? Where I'm breaking down my document into smaller and manageable pieces, right? Smaller and manageable pieces. It is not just smaller, the information inside that chunk also should be relevant, right? If let's say one single chunk is talking about A, B, C, D, E, F, G, right? These are multiple topics inside one single vector. So the resultant vector is neither representing A in true sense, nor B, nor C. So it is not actually representing the entire information about one single topic. It is taking let's say some part of A, some part of B, some part of C, and it may or may not come when, let's say, user asking some question on context, let's say C. Though this particular chunk has the information about C, right? But because it also has some other information, the information is diluted now. Now it may or may not come on my similarity search, right? On the similarity search score, it may or may not come closer to the user query vector, right? Hence, having a chunk which is having relatable information, right? Similar information is of is very important, right? Because this is what you are going to retrieve. This is what is going to get processed, right? So how do you break this document into smaller chunks, right? There are multiple strategies, right? Each chunk should have relevant information, easy while managing bigger document, right? So if you have, let's say, 500,000 pages in your document, let's say 500,000 is too huge. Let's say you have 300, 400, 500 pages in your document, right? You don't want to send entire information to your model. You break it down into smaller chunks, right? And that is also going to help us in efficient retrieval. If your chunks are better, or if your chunks are of good quality, your retrieval is also going to improvise, right? Automatically, the information that you are going to retrieve for the user question is automatically going to be the most relevant information, right? If you're not messing up with the too much information in one vector, right? Then you can expect a better result, right? What are different types of chunking? So here are a couple of them. There are more, right? You can feel free to explore, but here are some that you can get started with. From easy to hard, we have all of them, right? So let's say we have fixed size chunking, where just like in our previous one, we were breaking at each page, right? We were not even considering whether a particular line is being broken down in between, right? Or a word is broken down in between, right? So in fixed size chunking, we define a, let's say, 100 character. I take 100 character, even if after 100th character a word is broken down in between, or a particular sentence is broken down in between, I'm not looking into that. I am just breaking down the document at a defined length, right? I'm using this fixed size of my chunking. Then I have recursive character text splitter, right? Where you are not breaking the word in between, right? You say that, okay, let me wait till the time this particular word is completed, right? So if your word is, let's say this was your one single word, and this is your 100th character, you wait till the time word is complete, and then you break this sentence. So whatever comes prior to this becomes one chunks, whatever comes after this becomes one chunks, till the time you have the, again, 100 plus whatever the extra character of the word remains, right? That becomes part of your chunk. Now one thing also in here is that you have a concept called concept of overlap. What this overlap is, so let's say this is my 100th character here, and this is my 100.05, right? 105. Now let's say I take overlap window of 10 character. So rather than this word starting from here, it goes 10 characters back. right? And from that point, the second chunk starts from this. There would be this overlap of 10 characters. This is what my overlapping is doing. Doing this exercise or doing this, having this overlap window can help us retain the continuity in the context across different vectors, right? It is not just abruptly I'm closing, I'm trying to do the overlap. Obviously, you may not have 10 character overlap. 10 character is very less. Maybe you keep 25, 30 characters, right? You can have that, and maybe your chunk size having 300, 400 characters, right? Depends. You explore if this particular strategy is working or not working, how is it like, but these are some of the basic ones that you can start with at least, right? Then you have sentence splitting, obviously, that if my word is not broken down in between, I'm completing the word, but my sentence is broken down in between. Why do we break down the sentence? Sentence might be talking about something, and because I'm breaking it down, the context might get missed, right? So I do that sentence splitting so that I'm breaking down it at sentence level, not at word level, but at a sentence level, right? These are pretty easier one, pretty straightforward, no-brainer to understand these, right? But then we have other chunking strategies which are a bit more complex, right? But better also, right? What is that? Let's take about our semantic chunking. Right. Specialized chunking is something that you define, you write those custom rules for a specific document, right? You define those rules. This is very custom and this is very specific to that document. If the document changes, the strategy may not be applicable, right? So that is very specialized to a document. That depends upon what kind of document you are coming up. Let's say you are dealing with legal documents, right? Legal documents has their own structure, their own formatting, their own way of writing things, right? So maybe you want to go with specialized chunking where you understand that, okay, my document, all the documents are going to be of similar structure. If I do those, if I have those custom rules, I can replicate it across all the documents that I am going to have in future, right? So that can be applicable depending upon what kind of document you are dealing with, but may not work always, right? Now let's see what is my semantic chunking, right? How many of you can make some sense from this particular term, semantic chunking? We understand semantic, we understand chunking. What exactly is the semantic chunking together?
Based on meaning, the chunks
Mhm.
are created or the words are grouped together.
Yes. But why do we say words? Why not sentences?
Yeah, sentences can be, yeah, it can be, but depending on yeah, sentences can be actually, but not long. Maybe depending on size, like small sentences, similar.
Yeah. Yeah. So maybe let's say we have words like the, are, is, and, right? These words by itself may not have a huge meaning, right? You may want to choose to delete those words when you are breaking down this document and putting them into vector store, but they do hold the meaning, right? They can help you understand the entire word. If even those punctuation can change the meaning of the sentence, right? So we'll be talking about sentences and not just the words, right? The sentence in itself can have a holistic meaning of what this particular sentence is referring to. One word can have its own meaning, right? But when this word is connected with the sequence, the meaning can be different, right?
Hmm.
Depending upon the scenario. So we will be taking at a sentence level, not at a word level, right? Now, on the sentence level, right? Just try to have a visual implication of this, right? Try to create a visualization that we are having, let's say, 50 sentences, right? These 50 sentences, I am having like 50 individual sentences in my document. For each sentence, I am trying to calculate the similarity my first sentence is having with the second statement, my second statement with the third statement, my third statement with the fourth. So I will have this similarity score. right? If my first statement and second statement are talking about something similar, then their similarity score would be on the higher side, isn't it? If the two statements are talking about something similar, their similarity score would be higher compared to two statements where they're talking about two different things, right? So I'll create this for each 50 statement. I do this only. I have 6 and like this for till 50, and I do this similarity score for each statement, right? Now I come up with that, okay. I break down the statement, or I break down this chunk wherever I find that this particular statement, wherever the meaning is changing. In my document, wherever the meaning is changing, let me break that on this document. So what will happen like this is, if I have my statement 1, statement 2, statement 3, which are talking about something similar, right? The similarity between 1 and 2 will be on the higher side. 2 and 3 will also be on the higher side because they're talking about something similar. And then we have sentence number 4, which is talking about a new stuff, which is not related to 3, or which is which is very relatively lesser related to what sentence number 3 is talking about. So here the score would be on the lower side, right? Since I have got a sentence which is not similar to what my previous sentence was, I get a particular what would you say, understanding that okay, now the meaning in my document has changed, right? I'm talking at meaning level. My first statement, second statement, third statement, at a meaning level, they were talking about something similar. I have a very high similarity score. But my fourth statement, the similarity score goes down abruptly. That means my fourth statement is talking about something new, which the first, second, and third statements are not talking about. And hence, I can break the document at sentence number 3. And this can be dynamic, right? Let's say my first statement is it is coming at sentence number 3. Now my sentence number 4, 5, 6, 7, 8, 9, 10, they are talking about something similar. They all can be clubbed together into one single chunk because I'm doing this consecutive similarity, right? Does this make sense? And you may come up with the question that how do we say that what is the higher similarity, what is the lower similarity, what could be the question, right? How do I know that even if the sentence are talking about something similar, their similarity score can be zero point 0.8, right? Do I consider zero point 0.8 as a higher similarity, or do I consider zero point 0.9 as a higher similarity when I'm taking this decision of breaking down this document, right? What is that? How do you think we can handle this particular scenario? How do we know what is the higher similarity, what is the lower similarity? Zero point 0.8 is anything above 0.8 is similar. Are you saying that? If the similarity goes beyond like below 0.8, we break down. Is it? Okay. And how did you come up with this number of 0.8?
I think we can use percentile.
Mm-hmm. Yeah, probability, okay, but we have another option for percentile, yes, where I'm not just looking at two sentences, I'm looking at the entire document that I have, right? I have my maximum similarity that can exist in my document. I have the minimum similarity that can exist in my document, and based on the percentile, I can take the 80th percentile, yes, and that 80th percentile may not be point, it may be 0.7. Yeah, cosine similarity is the score that we are going to get. This 0.8, 0.9 that we were talking about earlier, that was similarity score, cosine similarity only, right? But this this percentile, right? I'm taking in general. overall, if even if my sentence or even if my document changes, right? If the similarity score between the two sentence is at a certain percentile cutoff, right? I am going to consider them into one single chunk. If it is going below that percentile, I can easily switch my chunk, right? And this percentile, 80th percentile, sometime can be 0.8 similarity score or 0.9 similarity score or 0.6 or 0.5 also for that matter, right? The idea in here is not to see just the two chunks in isolation. I want to have this over my entire document. By doing this percentile, I am doing this, I am considering the overall similarity score that I have across sentences in my document. Right? Does this make sense? Why are we considering percentile and not just the absolute number? Yeah. Okay. Perfect. For related to this percentile, you will get this document, or not just the percentile, the chunking strategy. Let me see what exactly is this. So on your GitHub, under week 3, you have this notebook which is talking about different splitting techniques, right? Different chunking strategies. Try running this notebook. You may encounter some error. Try to debug those errors, right? The idea in here is try to understand what is happening there. Okay, why is it not opening up? Maybe you guys can just open it and see if you are able to access it. Under week 3, you will have this notebook called allsplitting.iponb. It is opening up on mine as well. Yeah, here it is. So, and okay, let me clear this one more thing, that your RAG solution starts when you have already read information from your document, right? Your document can be a PDF document, your document can be a doc type, it can be your text type, it can be your markdown type, it can be HTML, it can be any other document, right? Once you have read the document, then this processing starts, right? Reading the document, extracting the information from the document is not part of this architecture. Right? We are talking that we have read the information. The information source can be, I experimented around that I'll have something like, I'll give you the, so I'll upload my YouTube video link, right? And automatically I'll have backend setup which is going to generate the transcript from that video. And on the transcript, my RAG operation will perform. Right? Does this make sense? So reading the information from the document is not part of this pipeline. This pipeline expects that you have read the information, you have cleaned the information if that cleaning is needed. If there are images, you may have removed those images and put in that text, the transcription of that particular image that is available, right? The description of that particular image, right? All that formatting that you have done. Second underlying disclaimer would be that this particular solution, when we are talking about RAG, is applicable only on that unstructured documents. To handle structured data, there is a completely different solution that you may want to build, right? Particularly, this is not applicable for your structured data where you have tables, where you have columns, you have rows, millions of rows, you have data, you have n number of columns, you can have n number of tables in your database, right? It is not applicable there. It is applicable only on that structured document we have, PDFs, different types of PDF doc, or if you have video, the video converted to text and all that stuff, right? It is primarily built for the unstructured use cases, right? Does this make sense? Okay, so let's just take a look at the splitting technique. Again, I'll just quickly walk through this. We have already discussed. So in character text splitting, I'm just taking the chunk size of 350 and I'm taking overlap of 0 in here. This is what I get in the output. Again, here let me discuss one more thing. That is my document data type. So if you see, you have this page content. What is this page content, right? So there is a defined data type by LangChain, right? And the data type is called document itself. This is your document data type, right? It is defined from LangChain, right? It is part of their package, where this document data type is something that by default your vector store. There are many other things that becomes easier for you to manage when you are putting it in this particular. Some of them are, let's say you are breaking down this document, right? How do you tell the model that which particular part needs to be converted to vector? Or for that matter, when you are putting it into vector store, right? There has to be a certain structure in the input sequence. You need to put the information in certain fashion so that model understand that, okay, information available under a specific key needs to be converted to vector. And then there is specific key called, let's say, metadata, which needs to be stored as a metadata. There has to be this standard structure of that, right? And this document is part of it. The vector store expect it in this particular fashion. We'll see how you convert all those vectors and everything, right? But this document data type is defined. It has a couple of things, right? One thing it is called page content, right? This particular thing. What is this page content? Page content which actually store the information, the actual text that needs to be converted to vector, right? The actual text, whatever you put in this particular format or this particular key, right? Page content, this will be converted to your vector, right? Any other information that you put it in your metadata, this is again going to be of text type. Metadata information, that is, there is another key called metadata. This metadata is again a dictionary, right? Whatever the key value pair you put in here will be stored as is in your vector store, right? No processing, nothing will be done from your vector store side, right? Vector store is going to take this text, convert this embedding and put it in your vector store, right? When you are retrieving them, again, there can be two ways of how you retrieve. We'll talk about that when we jump to that. But metadata information is stored as is. Your page content information is the text content, which will be converted to vector and stored. So if you remember our page content, I can store the clean information in my page content, which has removed the extra words, extra punctuation, extra those stop words, right? Extra white spaces, all that stuff. You have removed that stuff from your chunk, and then you are storing it, right? It can be your processed information as well. Then it's up to you. If you know that, okay, the information that I have processed is available in my page content, how to retrieve the original information. You may want to store that original information as part of your metadata, because nothing happen on your, right? You can use that metadata to filter, but it is not going to change. This page content is something that will change to vectors, right? So that's the format that you will have. Right now, when I'm doing this character text splitting, right, I'm passing this reference that I have this text available and I'm creating these documents. The format by default it is going to be the list of documents, right? Each chunk is going to be one item, or within this list, each item is going to be one document or one chunk, right? Each document is a chunk, right? So I believe you are not confused that we are talking about the initial 5,000 pages information that we are taking. We are also calling it as a document. right? So that is a document by meaning that I am referring to. That you have a document which is of XXY pages and something, right? This is a document data type, similar to data type that you may have you may want to have a specific data type for certain variables, right? You define that, okay, X is going to be an integer only, right? You define in some of those languages. Here you want to put this constraint. This is a defined data type. This document is the data type. And with this document data type, you have these keys where you have page content, you have your metadata, you have all this information, right? So does this make sense? That's why to access this information, I am putting it in this particular fashion. Okay, perfect. Yeah, now let's scroll down a little, right? So if you see, I am doing an overlap of 0, right? And this is how the first chunk will look like. And if you see, this word has broken down in between. The first chunk, I don't know, it is revolution or what is it, right? But when I see the second chunk, the second one starts where the first chunk has ended, right? So you can have this kind of problem when you follow the static methods of chunking. But okay, it is good to start with at least, right? Then you can understand, okay, what are the challenges in the type of chunking, and then you can think of how you can improvise. You can explore different ways, right? So this is there. Then let's say I do a overlap of 40, right? I'm doing a overlap between two chunks. Chunk size will still remain 350, but doing a overlap of 40, right? So even though my first word is breaking at that's the way the earlier one was breaking down my sentence. But second one, I am taking this. So if you see this it was breaking down in here. So I'm taking this overlap. I am doing this overlap so that my second chunk is also following up the context from the first chunk, right? I'm doing this. So again, like this, you will have across, right? This is my recursive character text splitter where my word is not broken down in between, right? At least I'm able to complete the word that I have, right? Document specific. We want to explore document specific, it has to be very custom, right? So this unstructured is one package, right? Which can help you in breaking down these documents in this particular fashion, right? So if you see in here, you have narrative text. This is a text type. This is your title. Again, you have your title, you have your text, right? You have your list item. These are your bullet points, right? So it can give you, so it's like how you extract this information from your database, right? This is where you can take a look, right? And then you write those custom rules that, okay, from title to title, there is one chunk, right? And like this, you can have the custom rules defined. Oh, now let's see other methods, which is my semantic chunking, right? Over there, when you give the correct file path, automatically this error will get resolved. Okay, don't bother with that. So first of all, I am breaking down this into sentences, right? Individual. I want to have first sentences, right? Once I have the sentences, I'm going to have this like formatting just for my ease. I want to have proper formatting so that I can connect it. Okay, in this list item, which particular sentence is this? What is the similarity score and all that stuff? I can store in here, right? So this is the actual sentence. This is the index. Also, if you will see, I am doing something called as combined sentences, right? So rather than just taking, right, I'm just comparing first sentence, second sentence. This may not be always the best method, or maybe I want to use some buffer, right? Sometimes the sentence is not like the meaning of when like to change the meaning, it is just abrupt one single sentence. Sometimes you use to connect two different logics through some bridging sentences, right? Where you are doing, let's say, some sort of comparison where your statement one is talking about topic A, statement third is talking about topic B, and then you have a bridging sentence in between, sentence number two, which is talking something about A and something about B, right? That is being that comparison so that you can maintain that flow, right? So to handle this kind of scenario, you can add something called as buffer, right? You can define a buffer size. You want to keep a size buffer of one, buffer of two, buffer of three, that depending upon how you want to explore or you want to experiment with, right? So now I'm not going to compare my first with the first statement with second statement, right? I'm going to create this combined statement. Combined statement is going to be the current statement, whichever statement is currently under consideration, plus minus buffer size. But let's say I have a buffer size of 2, right? So for when it comes to the first statement, I'll do 1 minus 2. Minus 2 is nothing, 0, right? From 1 plus 2. So this will become my combined statement for first. Right? When I come to second, it will include first, right? Two. I'm going to do 2 minus 2. So I'm going to go till sentence number 0. I don't have sentence number 0. I'll go with 1, right? So I'll take 1, 2, 3, and 4. This will be for my sentence number 2. Combined statement I'm talking about. When it comes to 3, I'll take 1, 2, 3, 4, 5. This will become for my sentence number 3. So like this, I'm creating those combined statement which includes the current statement plus minus whatever the buffer window I want to keep it, right? So that if I'm doing this, so now if I'm doing the comparison between this combined statement 1 and 2, 2 and 3, even if the sentence is changing the meaning slowly, right? I can capture that part, right? And if the difference or the similarity is on the lower side, I can actually capture that, okay, it is captured not in just one single statement, but actually it has changed over a couple of sentences, right? That's where it is going to help us. And so that's why I mentioned that we are creating this dictionary which contains this combined statement. So for this current statement, index number 0, this was the original sentence at index number 0, and this was the combined statement which include the currents plus the whatever the buffer size that I have selected, right? You can have that, and then I'm going to convert this to embedding, right? So all this is converted to embedding, and I'm also storing the embeddings as well, right, in this particular dictionary. Once I have the dictionary, I'm calculating the cosine similarity, right? So if you see, I'm getting the first three similarity score. The first is they are talking about so like this is the similarity, right? Second, this is the similarity. Third, this is the similarity, right? I'm coming up with the similarity, but this is no. So I'm coming up with distance, right? So if you see, I am calculating the similarity and then doing 1 minus similarity so that I get the distance. And wherever the distance is beyond certain threshold, I'll break it, right? So it is just similarity, 1 minus similarity is your difference, right, between two vectors, right? Now, how do I say whether this particular point 1 is 0.01 is enough to break the statement or not, right? I'll do, so let's say if I plot this, this is how it is going to look like. But let's say I want to plot it, right? Based on certain threshold, I put a, let's say, percentile of how much? Have given a percentile of zero point 0.8, right? On a percentile of zero point 0.8, I want to break this down wherever the difference is going beyond zero point 0.8 percent, right? So if you see in here, my first chunk itself contains these many sentences. These are around how many? 12 sentences. The first chunk itself contains 12 sentences. The second chunk contains only one sentence. This chunk number 2 contains, this particular chunk contains two sentences, right? Do you see? Just based on the meaning, I'm breaking the document into variable sentence length, right? Does this make sense? What is happening in here? Yes, code implementation is just yeah, code can be implemented even if you give it to ChatGPT, right? But understanding the logic is the key in here, right? How things are working in. in this particular scenario. Okay. Now we have the chunks ready, and this is how it is going to look like. For chunk number one, if you want to, obviously, it just I'm doing that print statement, right? I am printing this. This is chunk number one, which will have 12 sentences. Chunk number two, which has how many? Like one sentence, right? And then this is the list of chunks that you have, right? List item. One item is one chunk in this particular list, right? Does this make sense? Any doubts, any inputs, any confusion? I understand this can be a little heavy, but this is a little important one. The one that is available beyond this point in this document is little more complex. Not complex in terms of understanding, but also complex in terms of computation, right? Time it takes. The larger the document, the larger time it is going to take. It is the cost, like cost inefficient, I would say. It is because embeddings are relatively cheaper. When you see the embedding cost, you can use open source embedding. If you use ADA embedding as well, the embedding models are relatively cheaper compared to your other model. And in this particular method of agentic chunking, we are not using the embeddings, but we are using the LLMs to decide the chunks, right? So first of all, are we on the same page till semantic chunking till this point of time? Yep. Do give it a shot. Do give it a try. Maybe you would need to change the file path, yeah, right? Or you can put in the text, right? And start processing from the text also. That is completely up to you, right? But the idea in here is do give it a shot, right? It becomes very important to get a hands on. Otherwise, things will be too complex for you to grab it, right? So let's just quickly discuss this agentic chunking also, and then we can close it for today, right? So in agentic chunking, what I'm trying to do, so there are a couple of things, and why I said that this is a little heavy, right? In terms of computation as well, it is time consuming as well, right? All that stuff. Why I said that is, first thing is each and every individual statement in here, right? Even if your statement has, let's say, 50 sentences or 500 sentences, your model, your LLM is going to take a look at each and individual statement one by one. Like you are going to have n number of calls, n is equals to number of sentences in your document, right? If you have 50 sentences, you are going to make 50 LLM calls, right? If you have 100 sentences, you are going to make 100 LLM calls, right? And you cannot run all of these in parallel, right? It has to go serially, one by one. You have to make that LLM call, because after every LLM call, there is certain input that goes as part of your next sentence, right? So that has to be there, right? This help is, let's say you have your document which is talking about, let's say, topic A, it is talking about topic B, and it is talking about topic C. Let's say it is talking about these three topics, right? About topic A, it has something available on page number 1, page number 3, page number 4, page number 5, and then page number 10, right? It is scattered across documents. Similarly for others as well, right? The information is scattered across document in this particular sense, in this particular scenario. Now, if I am just breaking it down sequential sentences, right? what if my sentence has sequentially it is not following up on the meaning, but the meaning lies somewhere, or the related information lies in some other chunk. How do I collect this information in one single chunk? If the information is scattered across document, right, at different places, how do I collect them at one single place, right? Store them in one single chunk and then do the processing. How can I do that, right? That's where our agentic chunking comes in picture, right? Where I have multiple hosts, right? What is the first challenge that we're going to see in here is that if my LLM, or so in this particular scenario, my LLM is going to take a look at each sentence. LLM is going to take a look. LLM is going to take a look is as good as, let's say, if I give you a sentence, right? And if that sentence contains words like uh, they, we, right? Some pronouns, right? Them, he, right? These kind of words, or if not the directly words, but the meaning that particular sentence is trying to capture, the context also relies on the sentence that exists prior to it, right? Maybe there is a paragraph that is talking about, let's say, topic A. Let's say it is talking about India, right? Every time it is not going to mention the term India, right? Sometime it can also mention the country, right? Which country is being considered in this particular scenario, if we talk about, right? So first of all, the first major challenge is that each and every single statement has to be a standalone statement, right? We cannot have a sentence which has dependency across different sentences, right? So that is the first task, which itself is challenging. You take you build the agent that is going to do this processing for you, generate all these sentences which are standalone, using the context, obviously the context that is being followed in the document, right? You generate those standalone sentences, right? Once these standalone sentences are generated, and obviously, then it depends upon what model you are using, right? If you are using a model which is, let's say, a lighter model, which is a open source model, which may not be able to understand the context, right? Then also it depends upon, it will have direct implication on the sentence quality that is being generated. What if it is not generating it the right way, right? Then maybe you want to use a model, obviously not scale it on the whole document at one go. Maybe you take, let's say, sample sentences, right? Let's say you take first page has, let's say, 30-40 sentences. You take it on a sample and try to see if it is working or not working. How is it working? How is it not working? What are the challenges? What are the scope of improvement? Then you do that experimentation and come up with, before you scale it on your entire document, right? That is one. So first thing is we create those standalone sentences, right? Once you have these standalone sentences created, now what you do, you obviously through your prompts and everything, what you do, you pass your first statement to your agent, right? And the task of this agent is going to be that uh, it understand what is being said in this particular sentence, right? And you have some predefined buckets. These are some predefined buckets, right? Agent is going to see that, okay, this particular sentence is talking about, let's say, India, right? What is specifically India? Maybe it is talking about geography of India, right? It then understand, okay, this particular sentence is talking about geography of India. Is there any bucket available that is talking about something similar? We have a bucket summary. We'll come there from where these buckets came in, right? So my agent is going to take a look at this bucket summary, right? And try to understand that whether this particular statement fits in any of the bucket or not. If agent understands that, okay, this particular statement is talking about India's geography, it sees that, okay, there is a summary about this bucket, which is also referring to something similar. It adds this content into this bucket and revise the summary. And it is not just one single LLM call, huh? By the way, there will be different LLM calls, but the idea in here is that the agent understands the particular sentence, the current sentence that is under consideration, right? And classify which particular bucket this particular statement can fit in, right? If the sentence fits in any of the existing bucket, it passes the sentence into that bucket and triggers to generate a new summary for that bucket, because now we have additional information available, right? Maybe through geography, it was talking about Indian Ocean, right? Where exactly it is located in Asia. Maybe it was talking about the Himalayas, right? What exactly it was talking about when it comes to geography, right? This aspect, this summary is updated on the new statement that has been added, right? If let's say agent says that, okay, this statement, the agent understands that India's geography is this particular statement, we cannot fit this particular statement in any of the buckets. What will happen? Agent will trigger the command to generate a new bucket, right? Put this sentence into this new bucket and trigger to generate the summary. Every time a sentence goes into any of the bucket, the summary is updated. If a new bucket is created, again, summary is generated for that bucket, right? Now, take it from the beginning, where we do not have even a single bucket, right? Let's take this scenario. We have the input statement and no bucket available as of now. The first statement comes in, agent sees that, okay, currently there is no bucket, then let me create one first bucket. The first bucket is created, the sentence goes into that bucket, the summary is generated. Second statement comes in, agent sees that, okay, one bucket exists. Does the second statement follow the same, any of the understanding which, so that I can fit it in the same bucket? Okay, I can, let me pass it in the same bucket and then update the summary. Right, for the third one, let's say for third one, it needs to generate a, right? This is my one, this is two, and this is my three, right? The third one needs to go in my new bucket and update the summary. Do you see? Each statement is going through a process, right? That's why I mentioned initially itself that it is a little intensive operation, right? It takes time to build these chunks. But on the other part, if this process is completed, the chunks that you would get are relatively of better quality. Even if the information is scattered across the document, you will have that information in one single chunk, right? Do you see that? Can you do that comparison in the quality difference that you would have? The purpose of chunk is to have similar information in one single place, right? That's the whole purpose of breaking down the document into chunks. But it also comes with its own cost. It can be time consuming. It can be resource intensive as well, right? You have to build a pipeline to handle all those scenarios, do the validation and everything, right? That is there. And this particular scenario is also implemented in this particular notebook. If you will see, that my purpose is uh, to have this sentence completed, right? So this get preposition, all these preposition that I'm using, I'm first of all cleaning up all those preposition, whatever the preposition that I was using, so that I can have a standalone sentence, right? Once that preposition is completed, this is how the sentence is going to look like, right? Once this is also completed, I am creating this. So this entire code is available. You can use it, make the changes, you can improvise on this. That is completely how you want to handle this, right? So all this thing is available in here. I have different agents. So right, this is my one agent which is going to update the chunk summary, right? If you add a new preposition to the chunk, new proposition to the chunk, you may want to update the summary, or else this could get stale, right? So if you do not update the summary, your agent will not have the understanding of what all exists in your database, right? In that, not the database, the overall chunk that you are generating, right? You will not have, and then you have your own chunks, right? You will have your own agent with your agent prompt, right? Again, You can improvise on this. This code was generated. It's been a while since this code was generated. So obviously you can try out new techniques of how you put in, how you write the prompt and all that stuff. But this is something that when written was working perfectly fine. Right. Then you have update chunk title, right? So each chunk will also have its own title, right? Which is generated through this particular chunk. So each chunk will have sentences, right? It will have chunk summary, it will have chunk title, right? So these all are going to help agent to understand what is inside that chunk, and this is something that you will be consuming it later on, right? Does this make sense? All this is available. These are different methods, right? Different agents that are created. So it is not just one single agent working. It is a complete pipeline that is being orchestrated. Flow is created, and okay. Feel free to go through this code. Try to. So I would suggest is try to run this code as is first, just as is, no changes. Just see if you are able to run this code as is without changing anything. Right? Once you are able to run it as is, then you go back and start making changes. Right? Am I supposed to be a paying subscriber to OpenAI to run your chunking code? Yes. If you are using OpenAI API keys, then yes, you would be you would need to pay like the you need to generate the API key, add those credits and run it. If you don't want to use OpenAI, you want to use some other model, you can make the modification in the code and trigger your own like the Grok one, right, which are not paid, right? You can try it out from there as well. But remember, it is going to, let's say, you have some 3 credits, right? Because you will be making multiple LLM calls. For each one statement will have multiple LLM calls, right? Remember, we are also asking the agent to decide whether it is going to go in existing chunk or create a new chunk, right? That is first. Second, once the agent decides that it is going to go in the new chunk or the existing chunk, you need to update the chunk title. You need to update the chunk summary, right? So there are multiple things that is happening behind the scenes, right? So you will have to uh, see if you are not exhausting all your free credits, or if even if you are able to exhaust your free credit, you should be able to come up. So let's not run it on too many sentences. The idea in here is let's not run it on 100, 200, 500 sentences. Maybe create some sentences which has some cross dependency. Maybe you just take, let's say, 15, 20 sentences, right? Which has some cross dependency. Information is scattered in this in these statements, right? And then you see how this particular strategy is working, right? And then you later on scale it to higher sentences if you feel this is good enough, and you understand how much cost it is going to how much expensive this strategy could be, right? That's where you decide. So here, if you see, this is my first chunk adding this. Chunk found this. So it created this. Chunk found it again added to this. So if you see, first the title was date and year. Second, the title became date, times, and titles. Right. So it is updating the title for each and every sentence. Right. Similarly, if you will see, so for all these, the chunk is already found. All this chunk is found. If you see here, the new chunk is created. Till here, it was talking about technological advancement and impact of on society in 21st century, right? Now the chunk, because there was new topic that has come up, and your agent decides to create a new chunk, right? How you can play around with the agent, right? Maybe you say that only if you are very confident, right? How exactly you want your agent to behave? You go and modify the prompt and see how the agent is behaving afterwards, right? So that is something that you can play around with, right? So it has created new chunks, it can add into existing chunk, all that stuff is already happening in here, right? So ultimately, see, I have a total of 5 chunks that are created, right? My chunk number 0 has these many instances, right? This is my chunk ID, this is my chunk summary, right? I have that is just the way you want to print and take a look of what is happening, right? Then you have first chunk, which has only one single statement. You have chunk number 2, which has 3 statements. You have chunk number 3, which has again a couple of sentences, right? Like this. You can have information that is scattered across the document at one single place, right? So you can go through this document. Yeah, I'll share the link. And for today, we have already crossed the time frame. I hope that is okay. But we'll definitely try to restrict it within the time frame. But I believe discussing this was important when we are discussing ranking strategy, because again, if we start this in our next session, we will have to again debrief on what we have discussed. So it's good that we close the topic, and then we can in our next session we can move into the next topic directly, right? We are not going through the same topic again. Okay, I have shared the link for this notebook. Do give it a shot. Do try this across different types of document, right? And again, I'm giving this a disclaimer that using the agentic chunking, if you're using the OpenAI key, just cross check which model you are using, right? I think in this one I was using 4.0 preview. But if you want to go with like to when you are starting with, even if you go on to cheaper model, that is also completely okay, right? Because it can be expensive sometimes, right? Yeah, so I'm using GPT-4. This is a pretty, I would say, relatively expensive model. Maybe you can go with mini models, right? GPT-4o mini or GPT 4 mini, right? You can go with some of those mini models. They are relatively cheaper and performance is also good enough. Or you can try it out yourself and come back with the analysis. Or you can change this. So if you want to change the LLM, you just need to come and change this particular line. Rest of the things will automatically fall in place. Nothing, you don't need to change anything. Just this single line and that's it. Okay. Yeah, perfect. Any doubts, any inputs, any comments? Yeah, thank you so much. If you have any doubts, any inputs, feel free to share that, else we can call it a day. That's all for today. Okay, are we good?
Yeah, thank you.
Okay, great. Great, then I will call it a day. Thank you. Thank you so much,
Thank you.
guys, for joining in. And do give it a shot, do practice, and come up with the challenges. We'll see how we can fix all of them. Okay. Okay, then have a good one. Thank you. Thanks for joining in. Bye bye.